All right, so I think this is recording. Let's take a look here at this quadratic inequality. First thing I notice is it's not being compared against 0, so I need to zero it. I need to subtract 30 from both sides. Negative 2 is the greatest common factor for all these terms, so I'm going to divide every term on both sides of the equation by negative 2. When I multiply or divide by a negative number, I have to remember to change the direction of the inequality, and 0 divided by negative 2 is still 0. So I want to factor this. With a leading coefficient of 1, a lot of people won't have to draw the x off to the side because they'll just visualize two numbers that multiply together to give us 15, that add together to give us 8 is 5 and 3. With the leading coefficient of 1, I don't have to make the table afterwards. I can just use the 5 and 3 directly. That's why a lot of people just do this part, the x plus 5 and x plus 3, in their head, and they don't even bother with the x. But if you're in the habit of the x, which is probably a good habit, go ahead and write it there so that visually you can see. And it's easy when you have it like that. It's easy to check as well. All right, so this is going to. I should copy it down and put sign errors are the enemy. I had just a minute ago I was doing this problem and made it a different sign error, and my answers didn't make sense, and I caught the sign error and just thought, well, rather than trying to explain it, I'm going to redo the video. Well, I almost made another sign error and just copying down the number from my x. So you've got to be very careful in the details and try and be as neat and organized as you can, and that might help a little bit. So these two numbers divide my number line into 3 regions. I need to decide whether to shade or not to shade these endpoints. Do I want to include negative 5 in my solution set or exclude it? And since the arrow is underlined, since we have equality, we're going to shade this in, and it's going to be in our solution set, and the same with negative 3. So now I'm going to pick a test point from each region, plug it in, and determine whether the resulting arithmetic is true or false, and then determine whether to shade or not to shade each region. So I'm going to try to be organized and do that in a table. I'm going to label my first column test point. My middle column, I'm going to write the expression. It could be the original expression, but I'm going to use the factored form because most of the time it's easier for me to do arithmetic when it's in factored form. But you may prefer to write down the original, and it might be smart to write down the original because what if you've made a mistake or something? Most of the time in these math problems, when you make a mistake, the mistake carries all the way through the problem, and very seldom does it just self-correct. All right, and this last column is the truth column. So if we look to region A, we want to pick a number that's smaller than negative 5. I'm just going to pick negative 6. When I replace x with negative 6, what do I get? I get negative 1, negative 3. That's a positive 3, and positive 3 is not less than or equal to 0. That's a false statement. So I'm not going to include that in my solution set. In region B, I'm going to pick a number between negative 5 and negative 3. So I'm going to pick, say, negative 4. And negative 4 plus 5 is a positive 1. And negative 4 plus 3 is a negative 1. That product is negative, and it's true that negative numbers are less than or equal to 0. That's a true statement. So I'm going to shade this region B. It's going to be in my solution set. So in region C, I'm going to pick a number that's bigger than negative 3. Well, hey, I'm going to pick 0. and I've got 5 times 3 when I replace x with 0, that 15 is not less than or equal to 0. That's a false statement. So I'm not going to shade that region. So here's my picture of my solution set. Now I need to write my answer using inequalities. Now sometimes out of habit I will say using integral notation, because most of the time in this class, as soon as the first part, the first section in skill 3 is to talk about integral notation, and we use it for the rest of the year right after we learn it. So, but for now, we're going to write this expression using inequalities. -5 is less than or equal to x, which is less than or equal to -3. In inequalities, if you have a compound inequality, the arrows will always point in the same direction, and they'll always point towards a smaller value, like -5 here. So this is my final answer. I hope that helps. Don't be afraid to ask any questions, and I will talk to you later. Bye.